Hello, good morning. My name is Taufik Alif Kurniawan. I am lecturer of this class. For the first time, we will talk about the measurement instrumentation. After completing this class, the students are able to explain the definitions of measurement and instrumentation in the field of electronics engineering. I hope you enjoy with this class. Today we will talk about the measurement and instruments. What is the definition of measurements and instruments? And what is the function of the measurement instrument? And what is the purpose we measure something? So we start with the terminology. In general, the instruments are put to use and classified as follows. The first one, this is the function of measurements or instruments. The first one is monitoring of process and operations. The second is control of process and operations. And then the last one is experimental engineering analysis. Some measuring instruments have only a monitoring functions. For example, we have a thermometer and barometers. Okay, they indicate the condition of environment and cannot control any functions. So this is the function of monitoring. And then the second, it is the control and process of operations. Okay, some instruments are put to use for the control of process operation. For example, we have a home heating system using thermostat control. A temperature measuring instrument sends the room temperature, and then it will be provide the informations necessary for proper functions of the control systems. So not only monitor the something, in the second instruments has another functions. This is the control of process and operations. And then the last one is experimental engineering analysis. So we use the measuring instruments for the carrying out the experiments, such as measurement of voltage, currents, power, and also many aspects in engineering. So the application of instruments is to measure something, and it will be intended for the experimental purpose only. So this is the terminology, what is the instruments. And then we have the advantage of instrument system. The first one is remote measurements. And then we using the instrumentation system, we will have the accurate measurements. And then another advantage of instrument system is measurement in adverse conditions, just like nuclear reactors, space applications, etc. And then another advantage of the instrumentation system is convenience. This means that we can record of data, we can print out the data. And the last one is the advantage of the instrumentation system is we can reduce the size. Okay, so this is the block schematic of measurement system. We have measurements. Measurement is quantity to be measured is called measure. So this is the quantity to be measured. And then the second one is transducer. Transducer is device that converts a physical quantity into an electrical quantity or vice versa. It's like we have the antenna, we have a sensor. So this is the transducer. Convert from physical quantity to electrical quantity. After we have the electrical quantity for the physical quantity, we can measure it. And then the third one is signal conditioning. In signal conditioning, we have some work here. It's like amplifications. using the amplifier, filtering using a filter, modulating using modulations or demodulations. And modulation we use in transmitter, and demodulation we use in a receiver. And also we convert from the analog to digital conversion, or AD conversion, or the digital to analog conversions. And then the last one is display or record. So the quantity is recorded using the XY or step chart recorder or displays and monitors. So this is the block schematics of the common measurement systems. And what is the objective of measurements? So the first one, the objective of measurement is to establish the validity of the designs. And the second is to predict the limits of the capacity. And the third one is to provide the information needed to supplement further analytical work. So this is some objective of measurements. And the type of instruments to be used depends upon the type of the data. So the single type of the instrument is related to the single type of the data. So the data are classified as follows. The first one, we have the steady state data. Steady state data is if the data vary in the range of 0 to 5 Hertz. It's very low frequency. And then we have the transient data if the parameter variations is at a much higher rate, larger than 5 Hertz. So the third one is dynamic data. Dynamic data is the parameter variation is periodic. And how to measure the quantity of the object? We can use the analog or digital instrument here. Okay, this is the some comparison between the analog and digital instruments. For the analog, it has the low precisions, but the digital is high precisions. And then for the analog, we have the continuous stepless deflections, but the digital we have numerical readout. And then the analog is more flexible, but the digital is limited flexibility, different instruments for various range and applications. And then for the analog, we have the frequency response is large, from DC to low frequency range to high frequency range. But for the digital, frequency response can be very high. But for the analog, it will have the paralog error is possible to read out. But for digital, is no such error due to the digital display. So it will be not convenient for read out for the analog, but for the digital is convenience in read out. And in analog, we can find many errors like frictions, spring tensions, but for digital is no such errors. And no direct PC or micro PC or micro C compatibility, but we can comply with microprocessor, microcontrollers, and personal computer. Okay, this is some comparison between the analog and digital instrumentations. And then when we measure something, we have to measure the performance characteristic. And we have two characteristics here in the measurements. The first one, we have the static characteristics. And the second one, we have the dynamic characteristics. So we start from the static characteristic. We have many characteristics in the static. The first one is accuracy. Accuracy, precision, expected value, sensitivity, resolutions, error, repeatability, reproducibility, drift, dead zone, thresholds, and also limiting error or guarantee error. This is some static characteristics. And for the dynamic characteristic, we have the fidelity and speed of the response. So this is some performance characteristics for the measurements, and the dynamic characteristic of instruments are represented by the differential equations. So the order of the equation represents the order of the instruments. So in the general, instruments are classified as a three category. The first one is zero order. So for example, the zero order is linear potentiometer. So the zero order instruments is represented by the equations A0y is equal to Bx, where the A0 and B is the constant and X is the input, X is the input, Y is the output, and A and B, this is the constant. So this is the zero order instruments. For example, a zero order instrument is potentiometer. And the second is first order. First order, the equation of the first order instruments is A1 dy per dx minus A0y is equal to Bx. Okay. This is similar. The y is the output, the x is the input, and A1, A0, and B is the constant. Okay. For example, is mercury thermometer. And the last one is the second order. Okay. The equation of the second order instruments is A2 d quadrat y per dx quadrat plus A1 dy per dx plus A0 y plus bx is equal to 0. So this is the second order. So please open the mathematical engineering. So this is the second order differential equation, and this is the first order differential equation, and this is the linear equations or zero order equations. For example, for the second order instrument is spring balance. Okay, so for the performance characteristic in the instrumentation and measurement, we have some type of the error. Okay, and the errors is classified into three categories. The first one is gross errors or human errors. It's affected by the operator or persons using the instruments. And then the second is systematic errors. The systematic errors are divided into two categories. The first one is instrumentation error, and the second the one instrumentation error, and the second is environmental errors. So the instrumentation error is due to shortcoming of the instruments, and then the environmental is due to the external conditions affecting to the instruments. Okay, for the instrumentation error, maybe some example is like a frictions in bearings of various moving components in the instrument, or calibrations error, and also zero setting or full scale setting or faulty display circuits. And environmental errors like ambient temperature, pressure, humidity, magnetics, many aspects affected by the environmental. And the last one is random errors. Random error is no specific reasons can be assigned, and maybe it could be taken to avoid these errors. So this is the type of the errors in the measurement and instrumentations. Okay. This is all of our class today. Please see the material in AMAS and also in the book. Do the exercise and homework. Enjoy your day. Good morning.